Hello, everyone, and welcome into another episode of Going to Attic Space. My name is Jason Boning. I'm the owner of Uni-Serve Air Conditioning in Houston, Texas, where we maintain, repair, and replace HVAC systems. So today, there's a couple things I want to talk about. I want to talk about heat pumps and the 25C federal tax credits. The heat pumps are a large part of that. And so I thought a good place to start would just be by simply talking about what is a heat pump. So, you hear, okay, do you want an AC or a heat pump? And a lot of people are like, what? Here in Houston, I need AC, so why would I want a heat pump, right? Does a heat pump just pump heat, right? So there's definitely some confusion around that. And so simply put, a heat pump is an AC that can run backwards, all right? And so let's talk about it a little bit. I won't go too deep in the weeds, but essentially an AC, and the refrigeration cycle has four parts to it. All right, so there's the compressor, and then there's the condenser coil, and then there's the metering device or the expansion device, which in today's systems is either a TXV or an EEV. So a TXV is a thermostatic expansion valve, and an EEV is an electronic expansion valve. And then there's the evaporator coil. All right, so just kind of walking you through that. So in your outside unit, you have the compressor. The compressor is in the middle of your condensing unit. And then wrapping around that compressor and kind of making up the box, if you will, that is the condenser coil. Okay, so you have your compressor and your condenser coil in the condensing unit or the outside unit. And then inside, in your inside unit, you have an evaporator coil. And typically inside that evaporator coil, or either right before you get to it, is that expansion device, which I said earlier is either the TXV or the EEV. So what happens is your compressor is pumping the refrigerant, and at the compressor, it compresses the refrigerant into a high pressure gas. And then as it circulates through the condenser coil, that refrigerant is condensing into a liquid, and it becomes a high pressure liquid. And then it's pumped to your inside unit, which is typically up in your attic or maybe even in a closet. And then it goes through that expansion device. And as it does that, it immediately enters into your evaporator coil. And that's where the refrigerant then evaporates and essentially becomes really cold. So it's absorbing heat at that point. All right, so it gets really cold inside that evaporator coil, and then the air is passing through that evaporator coil on kind of the other side of the refrigerant, if you will. It's a heat exchanger, and so it's passing through. And then the air is releasing the heat, kind of giving the heat, if you will, and then the refrigerant's absorbing that heat, and then it starts all over. Then it goes back outside to the compressor, condenser coil, expansion device, evaporator coil, and it just completes that cycle. And then inside and outside, you have kind of other things happening with the air passing over those coils, which are heat exchangers. So, all right, I tried to cover that kind of as quickly as I could and in as much detail as I could. But that's the refrigeration cycle for an air conditioning system. Now, if you have a heat pump, what the heat pump can do is just reverse that cycle. All right, so like I talked about, in a typical AC, you have your evaporator coil, and it gets really, really cold, and then the air passes through it. And so a heat pump, when it reverses the cycle, then what happens is the condenser coil outside is the part that gets really, really cold, and then the evaporator coil inside, that starts to act as the condenser coil, and it actually gets really hot, and it's releasing heat at that point. So instead of your outside unit releasing heat or rejecting heat from the inside, it reverses it so that it's rejecting the heat inside. And then the air that passes through it in your home starts to get really warm. So you may be thinking, well, what if it's 30 degrees or 40 degrees outside? There's no heat to be transferred, right? How can that heat then be transferred into the home? And so it's just physics. All right. And so even though it's really, really cold to us, there's still some amount of heat that can be transferred through that refrigeration cycle to the inside. And then we also get the benefit of the compressor heat that can then be used to heat up your home inside. So, yeah, I wish I could get on a whiteboard and kind of draw some of this stuff out, but in this podcast, I'm just trying to relay it verbally the best I can. But just to summarize once again, a heat pump is an air conditioning system that can essentially run in reverse. And so it's almost identical to a typical AC system. The main difference is that you have what's called a reversing valve in that unit outside. So instead of a condensing unit, we refer to it as a heat pump, and that heat pump has a reversing valve. Now, in the greater Houston area, we don't see a lot of heat pumps. So natural gas is very prevalent in this area, and so we have a lot of gas furnaces. And for that reason, we do not see a lot of heat pumps. Additionally, I think heat pumps, well, I know this, they were not made, maybe a decade or two ago, they were not made like they were made today. And so the reliability was not as good. And then also once the temperatures got below, say 50 degrees, they really started to struggle. Whereas now the technology and the reliability has come a long way. Just to give you an example, I have a heat pump on my house, and over the past couple years, we've had some pretty cold weather and even gotten below freezing a few times. And I hadn't even turned on my furnace, which I'll kind of get to in a minute. Furnace, heat pump, how does that work? So my furnace hasn't even come on in a couple years. I've been able to rely on my heat pump even when we get below freezing. And the reliability has been really great. So as I mentioned before, I have a furnace as well. So you're like, furnace, heat pump. So typically in an all-electric system, you'd have a heat pump matched up with an air handler. And the difference between an air handler and a furnace is that an air handler has the blower motor and then an evaporator coil all in one unit. Whereas if you have a typical AC system, you have a furnace which has the heat exchanger and the blower motor, and then you connect that up to an evaporator coil. And that's a typical gas system. What we can do today is we can do either one. We can put a heat pump outside with a furnace and evaporator coil inside, or we can put a heat pump outside and an air handler inside. And so the main differentiator there would be basically how your home is designed. Do you have, what's the electrical system like in your home? So a furnace runs on 120 volts, 120 volt circuit, whereas an air handler requires a 230 volt circuit. So if you have an existing air handler, we're just going to go back with an air handler and match it up so that you don't have to get an electrician and change up the power circuit. If you have a furnace inside on 120 volts, then we can just keep the furnace and put a heat pump outside, and then you'd have what we'd call a dual fuel system. So that means that you could heat using the heat pump, which is going to use an electric heat, just an electric heat source, it's using electricity to power the heat pump. Not like necessarily like like a blow dryer with a heat kit per se, or a heat kit and an air handler. Or you can use your gas furnace to heat, which you're using natural gas. So the dual fuel being either electricity or natural gas. So that's what we call a dual fuel system. Okay, so I know I've thrown a lot out there. So just to summarize a couple things, a heat pump is an AC that can run backwards. And whether you have an air handler running off of 230 volts in your home or a furnace running off of 120 volts, we can still put a heat pump outside and configure it either way, okay? So if you're thinking about, you're seeing stuff like get a heat pump or get this tax credit and take advantage of a heat pump, then yeah, you absolutely could do that. And a couple things to be aware of. Heat pumps, they are more expensive. There's more to it. And so it's going to be more expensive. Also, depending on Whether you go with a single speed heat pump, let me back up a little bit. If you go with a single speed heat pump, you are going to have more thermostat wires that run outside to be able to control that heat pump. If you go with a communicating variable speed heat pump, then you can probably get away with just the 2 wires that you would have running outside at the moment. Once again, I know that's a lot to think about. If you are interested in a heat pump, that's something we would take a look at and let you know how many wires are running outside and what voltage is the circuit up in your attic or for that inside unit, and help you make those decisions, and just inform you of everything that's existing, that's already there. So I guess the big question then is, should I switch to a heat pump? And a lot of the reason, as I mentioned before, that people are considering that is due to those federal tax credits. So you could actually get a $2,000 tax credit by switching to a heat pump. Now, with that said, there are some requirements when it comes to the efficiency of that. You can't just get any heat pump. There are very strict requirements. And so this year, for 2025, there's actually 2 different paths. And so I'm looking at the numbers right now. There's a path A and a path B. And the 3 factors that it considers is the SEER 2 rating, the EER 2 rating, and what's called the HSPF 2 rating. All right, so let's talk about a couple of those numbers. So first off, the SEER 2 and the EER 2, those are very similar. So EER stands for Energy Efficiency Ratio. And then the SEER, or the SEER, which we hear a lot more often, that's the Seasonal Energy Efficiency Rating. And the 2, it gets really complicated, right? So the 2 aspect, that came into play in 2023. So in 2023, a new rating method was put in place by, we won't get into all that. So a new rating method that went into place in 2023, okay? And everything then became 2. That's just the new rating method, all right? Let's just stick with that. And so you have a SEER 2 and EER 2, okay? And really the numbers that you're looking for there with the heat pump is going to be 16. So if you want to get to that $2,000 federal tax credit, you have to have a 16.0 SEER 2. Now, the next, as far as path A and path B, that's the difference between either the EER 2 and then the HSPF 2. So for path A, you have to have a 9.8 EER 2 and an 8.5 HSPF 2. Whereas for path B, the EER 2 has to be 11.0, and then the HSPF 2 has to be 8.0. All right, so it's just a difference there between EER 2 and HSPF 2. And just to give you a little more insight there, so what are those EER numbers? So the EER, that's a measure of the amount of energy that's input into the system and how much cooling capacity is generated from that. All right, so how efficient is it based on how much electricity is put into it? The HSPF, I got to look that up here. I always forget what that is, but the HSPF stands for Heating Seasonal Performance Factor. Heating Seasonal Performance Factor, okay? And so that is a measure, or that's a rating specifically for heat pumps. So an air conditioning system is going to have an EER value and an SEER value. And I guess I forgot to mention, the main difference there is that the SER is the Seasonal Energy Efficiency Rating. So that's going to be basically looking at that EER rating through a cooling season, whereas the EER is looking at it kind of more holistically. And then the HSPF, like I just mentioned, that's the Heating Seasonal Performance Factor. So how well is that heat pump going to heat is essentially what that means. All right, so I know I'm throwing a lot out there here, and lots of data here. And so, like I mentioned before, the main thing to keep in mind is that you can get a $2,000 federal tax credit, and the heat pump it's got to meet those numbers based on either path. It's got to have at least a 16.0 SEER2, and then the EER2 and HSPF that for path A, one's high, one's low, and then vice versa for the next path. Now, the question is well, how much extra is that going to cost to get me that $2,000 tax credit? And I'll just be upfront with you. A lot of times it's going to be from a typical AC system to a heat pump system that has these minimum ratings, if you will. It's going to be maybe $1,500 to $2,000 more. Okay, so you almost spend what you're going to get back in that tax credit just from equipment cost and the little additional labor that's required to install it. Now, the benefit that you get though is it can actually, it can be great, but it's really on the heating side of things. And so you may be thinking, well, we're in Houston, we don't need heating, right? But we have no idea what's happening with, electricity and our grid and natural gas. And so if you do have a gas furnace, I think being able to have that dual fuel setup where you can heat using your heat pump or you can heat using a gas furnace, I think that's a pretty big value. If electricity spikes or natural gas spikes, in the pricing, you can switch to one or the other in terms of how you do heat your home. So that's a big thing. If you already have a heat pump or you already have an all-electric system, then I think going with the heat pump is a no-brainer in that point. So yeah, there you have it. A couple paths there for upgrading to a heat pump. Last thing I'll talk about. So there is a federal tax credit just for efficient AC systems. And just to give you some numbers there, you can get a $600 federal tax credit for an AC that has a 17.0 SEER2 and a 12.0 EER2. And so if you're looking at maybe a variable speed system or something that's on the high end in terms of energy efficiency, that's definitely something that you can be on the lookout for as well. Last thing I'll mention, I've thrown out $2,000 federal tax credit or a $600 federal tax credit. And so that's, just to note, there is kind of more to that. So it's either 30%, it's a 30% rebate of the cost of the job up to those numbers. But if we're looking at the cost of air conditioning systems and heat pump systems today, the 30% of that job, you're definitely going to max out at either that $600 or $2,000 number. But I definitely want to just mention those so that you're aware. Okay, that's a lot of numbers. So I hope that helps. Hope that gives you some insight into what is a heat pump, what's the difference between a heat pump and just a straight air conditioner, and give you a little more insight there for whenever it's time to upgrade your system, and maybe you do want to consider a heat pump. If so, let us know. We'd be happy to come take a look at your system and give you some more information.